A very warm good morning to all. I am Saisri. Today we are going to discuss on a topic on additive manufacturing. Before starting, just see one video. As we have seen in this video that how the birds build their nest with the help of grass by layer upon layer. Similarly, additive manufacturing also the addition of material by layer upon layer. So I am going to introduce to you what is manufacturing. Secondly, I will say what are the types of manufacturing. Third one is what is additive manufacturing and its history. What are the technologies are used in this AM process? What are the stages of 3D printing? How it works, advantages, disadvantages, and applications. So let us come to our first point. What is manufacturing? Manufacturing is derived from Latin word manufactus, which means made by hand. But in this young generation, it includes the creations of models with the help of hand, machine, and computer. In simple words, we can say manufacturing is the process of converting raw material into finished good product. As you can see in this diagram, we have taken input as a raw material, then it will process, it will reprocess, it will be machining, and finally we got the output here. So let's come to our second point. What are the types of manufacturing process? Mainly there are three types of manufacturing. They are formative manufacturing, subtractive manufacturing, and additive manufacturing. As you can see in this diagram that you can understand for the term they are. Let us come to our first formative manufacturing. In simple words, we can say the formation of material in a process is known as formative manufacturing process. For example, casting, molding. Subtractive manufacturing process. The removal of material in a process is known as subtractive manufacturing process. For example, drilling in workpiece, tapping. Additive. The addition of material by layer upon layer is known as additive manufacturing process. 3D printing or rapid prototyping is also known as additive manufacturing process. And my topic is about this additive manufacturing. Let us come to our next point. So these are the definitions that I have already told. Then what is AIM? AIM stands for additive manufacturing process. The process of joining of material to make object from 3D model data by layer upon layer. It is also known as 3D printing or rapid prototyping. It is a very advanced technology. Next, history. Hideo Kodama created this additive manufacturing in the year 1980. Then 7 technologies. Mainly there are 7 types of technologies. They are material jetting, wet photopolymerization, binder jetting, material extrusion, dyed energy deposition, sheet lamination, and power bed fusion. Let us come to our first point, material jetting. Material jetting is also known as polyjet. In this process, we can use multiple colors to get multiple colored output. Material is deposited from a nozzle which moves horizontally to the build platform, and then the material is cured by using UV light. Next point is bed photopolymerization. Bed means a tank and polymerization means plastic. Bed photopolymerization technology utilizes a photopolymerism in a bed and that is cured by using light source. Mainly there are two forms of bed photopolymerization. They are SLA and DLP. SLA stands for stereolithography, DLP stands for dyed energy deposition. And then binder jetting. A liquid bonding agent is applied through inkjet print head bonding particles together. The build platform will be lower and then the next layer of powder will be laid on the top side of the machining. Then metal extrusion. In this process, the spool of material, usually thermoplastic polymers, are used in this process to cure the material and the machine is connected to the x-axis and y-axis and z-axis is connected to the build platform. Mainly there are 3 forms. FDM, FFF, and FLM. FDM stands for Fused Deposition Modeling, FFF stands for Fused Filament Fabrication, and FLM stands for Fused Layer Manufacturing. Let us come to our next, Dyed Energy Deposition. In this process, metal is melted upon the deposition with laser or electron beam with powder. Then sheet lamination. In this process, metal sheets are used and laser beams are used to contour off each layer of the process. Next, powder bed fusion. In this process, heat source is used to solidify the material in powder form to 3D model. There are 5 energy sources in this powder bed fusion. They are SLM, EBM, DMLS, SLS, and SHS. SLM stands for selective laser melting, EBM stands for electro beam melting, DMLS stands for dyed metal laser sintering, SLS stands for selective laser sintering, SHS stands for selective heat sintering. Let us come down next slide. What are the stages of 3D printing? First, we have to design a model in CAD software or in Fusion 360-degree. That design we have to convert into STL file. STL stands for Standard Triangle Language. STL file is used because it improves the security of the data. And then the data will be slicing. Slicing means it will do some of the calculations. Means we have to take how much length it will take, how much breadth it will take of the model. And then the data will send to the 3D printer. And then the 3D printer will design the final output. Let's see the working video.
What is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
Let us come to our next. What are the advantages? It is lightweight. It reduces the material waste, lower energy, design flexibility, and it is customized product. Disadvantages are it is limited model size, limited material properties, cost of equipment is high, long-term maintenance, and slow process. Next come to applications. Aerospace, defense, art and design, healthcare, food. Thank you.